All right, in this video, we're going to talk about transformations. Specifically, we're going to talk about transformations of exponential functions. So up at the top is a reminder of what the transformational function form looks like. We have talked repeatedly throughout this year about what A, B, C, and D represent. So we're going to get right into actually using the transformations. So problems number 1 and 2 say to consider each transformation of f of x equals 2 to the x. So this is your parent function, your base function. Describe the effects of each transformation. So we'll figure those out. Sketch the transformed graph g of x, okay? And then identify the key characteristics. All right, so I'm going to zoom in on number 1 here. And the first thing I'm going to do is I'm going to look at this function, and right here is 2 to the x, but here's how we've changed it. We've subtracted 3 from it. So what does subtracting 3 from the entire function do? This is a vertical translation, and that would be minus is down. Wow, that's horribly written. Let me try that again. There we go, slightly better. Down 3 units. That's the only transformation that's in this problem. So when I look at this, I see all these little red dots along the curve. Every single one of these points is going to slide down 3 units. All right, so let's see. 1, 2, here we go. Here we go. All right, 1, 2, 3. And 1, 2, 3. All right. Now, there's one other piece of information that I'm going to add before I draw my entire curve. And that piece of information is, and I'm going to put it in highlighter here, but I'm going to go pretty thin. This exponential function right here, this 2 to the x function, has a horizontal asymptote right here. And I'm going to draw that in highlighter. It's really thin, I know. That's okay. I'm going to erase it in a minute anyway. That piece, this horizontal asymptote, is going to move down 3 units. All right. So that, I actually want to put it in place. I'm going to loop it. There we go. I'm going to loop it and drop it down 3 units here, because that's actually going to help me draw my curve. All right. So when I go to connect the dots here with these points, I know that once I get past this farthest point to the left, I'm going to keep getting closer and closer and closer to this horizontal asymptote, but I'm never going to actually touch it. It's going to look like I'm going to touch it, but that's because I'm using a pencil that I can't get any thinner. All right, so I'm going to go ahead and connect the dots, curving up. There we go. So that's the rapid growth, and then let's go ahead and do some gradual growth down here. Kind of wobbly there because I was trying to draw it slow. But basically, we're approaching this horizontal asymptote, but we're never going to cross it or touch it. That's the whole point of a exponential function. All right, let's talk about some key features here. Domain for our exponential function has not changed from the basics, so it's -infinity to infinity. Now, the range is, we're going to look at how low we go to how high. Now, we don't actually ever get to -3 here, but we get real close to it. So we're going to use parentheses, -3 to infinity. Now, the asymptote I already talked about. This is this horizontal line in pink here. This horizontal line is going to be y equals -3. It's normally y equals 0, but since we had a vertical translation down 3, it became y equals -3. And then the intercept, there's actually 2 of them, but I'm not going to worry. I might figure this one out. I'm probably not going to. This one is the one that I want to talk about. This one is the one that dropped down from 0, -1. And now it is 0, -2. And let me see, how difficult would it be to find the other one? It's not actually that bad. So I'll go ahead and actually find the x-intercept here. Nope, I'm not going to. I lied. I was thinking about it. I was like, nope, that's going to require some math that I don't want to do. So we're going to specify that this is the y-intercept here. All right, so that's problem number 1. Let's go ahead and slide on over to number 2 here. All right, so we have the original f of x function, which was 2 to the x. I'm going to look for the transformation. So what's different is we've got a minus 4 here attached to x. So, it is attached to x. So what is happening here is this is going to be a horizontal translation. Apparently I need to spell that right. Horizontal translation. Now this is where, remember, the horizontal translations are a little weird. Even though it says minus 4, I'm actually going to slide up to the transformation form, or actually zoom out. So whatever's attached to x here, because the original problem was minus x minus the c value, if your c value on its own is positive, in this case the c value is 4, that actually means you're going to be moving to the right 4 units. So this is going to be a horizontal translation, right 4. So all of these points in red are going to stay on the same y value, but we're going to slide them all 4 places to the right. 1, 2, 3, 4, 2, 3, 4, 1, 2, 3, there we go, 4 and 4. Now, for my brain, it helps me to put in the asymptote. So I just keep making a very thin highlighter to put the asymptote in place. So that's going to be this x-axis right here. Now, shifting left or right isn't going to change that horizontal asymptote. It's the same asymptote because it's a line. It's going to stay the same width side to side. It's infinite. So we don't have to worry about that. I am going to go ahead and play connect the dots. I just realized I want to do green or blue together. So I'm going to go ahead and do, I guess, orange and blue. So let's see some drastic change here, and then trying to get this pretty close. And my hand wobbles a little bit when I draw this, so this should be continually getting closer and closer to the x-axis. I know it wobbled a little. I'm going to let it be. So there's my graph. That's the new function. Domain, we're still dealing with the same domain, negative infinity to infinity. Range, we didn't change the range here. Because we moved right, the range would be the original exponential range, which is from 0 to infinity. You have an asymptote here that was the same asymptote as a regular exponential growth function, which is y is equal to 0. Now our intercept, we have 1 here. It's different. All right. So that one we can actually figure out. And again, I'm going to specify this is the y-intercept. To find a y-intercept, I am going to make x equal to 0. So this is 2 to the 0 minus 4. This is what y is equal to. So y is equal to 2 to the negative 4th. Now, this is not going to give me a negative number. We know that because this is positive y values, and our line goes through the positive y values. What this does do is it gives me a fraction of 1 over 2 to the 4th. Now, let me do a quick check in my head. 2, 4, 8, 16. So my y-intercept would be 0 for my x value, right? We used 0 and replaced x with 0. And then 2 to the 4th is actually 16, so this would be 1 over 16. Now, you could throw that in a calculator and get the decimal equivalent. Totally fine. All right, so that's problems 1 and 2, where we're actually identifying our transformations and then graphing some stuff. Let's slide on down to 3 through 6. Now I'm going to say all, but all we're doing with 3 through 6 is identifying the transformations. I'm going to go ahead and do 2 of these. I'm going to pull 4 and 6, not for any particular reason, but I want to do those 2. 3 and 5 will be done in the key, so you can check your work on those against the key. I'm going to go ahead and slide in on number 4 here. Now, you guys probably by now know I'm a visual person, so I'm going to go ahead and highlight all the different transformations, so that way I make sure I identify all the transformations that are different. So if you notice, everything I've highlighted is everything except the 10 to the x. So all of those other pieces, the 1/5, the -3, and the -5, I need to identify what those transformations are. All right, 1/5. That is going to be a vertical compression by 1/5. We're going to make this graph 1/5 as tall, or 1/5 as far away from the x-axis. So it's going to get kind of squished. Let's see. We've got an x minus 3 here. We actually just talked about that one. That is a horizontal translation, and that's going to be to the right 3 units. And then last but not least, we have this whole function here, and then we threw a -5 at the end of it. So that is your vertical translation. And because it's subtraction, that was a straightforward one. So because it's subtraction, we're going to say that that is down 5 units. All right. So those are the 3 transformations for problem number 4. That's it. You're done. Okay. Let's go ahead and slide on down to number 6. And that'll be the last part for this particular video. So I want to identify, like, what are the changes? So I've got a 2 sitting here in front of my x. I have a -1 here attached to x. And then I have a +7 at the end of the entire function. So again, if I look at it, the only things that aren't highlighted are x to the 10th. So that way I know I have identified, or I have found all of the various pieces that I need to identify. Now, 2 of these, the 2 and the -1 here, are directly attached to x as part of the exponent. So they're going to be 2 horizontal pieces. So the first one, this 2 here, it's one of the goofiest ones that we deal with. It is a horizontal, and this is going to sound weird, but it's a compression. I know it looks like you're supposed to be stretching away, but it's actually, because it's horizontal, it gets all kinds of weird stuff going on. But anything that's multiplied times x that's greater than 1, and so in this case 2 times x, is actually a horizontal compression by the reciprocal, which would be 1/2. All right, and actually I lost the word by, so let me put that in there. So horizontal compression by 1/2. All right, the other 2 we've dealt with, right? X minus 1, we know what to do there. The +7, again, we should know what to do with that as well, but let's double check. So x minus 1 here is going to be a horizontal translation. Remember, that's just a fancy name for shift. Horizontal translation, -1 is going to be to the right. I know it's backwards. All right, to the right one. And then the last bit here is this +7. This is your vertical translation. And that one's straightforward. So it says +7, so we're going to go up 7 units. All right, so this is all about the transformations of exponential problems. So we did 2 where we were just identifying the transformations, and then we had 2 problems where we graphed our transformations and then identified some key features. If you've got any questions or concerns, please let me know. But other than that, I'm going to go ahead and cut the video here. I'll have a separate video for transformations on logarithmic equations.